start by just chatting for a moment about this question. If I said to you, find the distance between 7 and 11 on the number line. This is nothing complicated. These aren't points I plotted in the coordinate plane. What's the distance from 7 to 11? You would say
3.
3.
4.
I don't know who said 3, but that's on video. It would be 4 units, right? Now, how did you get 4? 11 minus 7. Now, here's the thing. You did 11 minus 7, and that's great. Could I have done 7 minus 11? Yes, as long as I took the absolute value of it. As long as I'm taking the absolute value, then I can subtract in any order that I want. Right? Now, absolute value is distance on the number line. So when the next question says, find the numbers less than 4 units from 7, how will we do that? We want all the numbers that are less than 4 units away from 7. So here's 7. We want to be less than 4 units away. So what would be the outermost boundary here if we want to be less than 4 units away? 11. And that would have to be an open dot, because 11 is exactly 4 units away, right? Not less than? But what if we went the other way? Because we're allowed to subtract both directions. So what if we went this way? What would be this boundary? 3. And again, it can't be included. It's an open dot. So would you agree that every number in between 3 and 11 is less than 4 units away from 7? So your answer would be 3, 11 in parentheses, because those are open dots. Now you're thinking to yourself, well, Mrs. Ford, I've really never seen a problem that was written out like this before. And you're right, you probably haven't. But you have seen it written this way. Believe it or not, that is the same question. How did you tell me you found the distance between these two numbers? You subtracted them, right? And we said we'll do absolute value to make sure everything stays positive since we're doing distance. So that says, okay, I don't know where x is. Here's 7, here's x. This says the distance between x and 7, the distance between them is less than 4. Now what I'm trying to do is open a new way of thinking for you. Because in calculus class, expressions like this are very common. Only they don't have numbers here, they have letters like epsilons. This literally says, here's the number 3. The distance between some number and 3 is less than 5. So what are the boundaries on that number? If the distance between some number and 3 is less than 5, what are the boundaries on that number? 8 and -2. So every number we need has to be between -2 and 8. This is a new way of thinking. You've never thought about it like this before. Let's try another one. Remember, when you see an absolute value of a subtraction, you immediately think, oh, that's a distance. That's a distance. This is a distance. That's a distance. So what does this say? Here's 5. X is somewhere, and the distance between, let's put it here for a minute, the distance between X and 5 has to be more than 6. The distance between X and 5 has to be more than 6. So what are the boundaries on X? If it has to be more than 6, what are the boundaries? 11 and negative 1? Now, are y'all seeing where we got those numbers? We said, okay, we got to be 6 away. So we'll go 6 to the front and 6 to the back. But this time, it's an or equal to. So I'll close the circles in this time, right? What's the other difference? This time, it's a greater than. They're more than 6 units away. Not less than 6, more than 6. So the answer to this problem is everything from negative infinity to negative 1. Union, very good. 11 to positive infinity. Perfect. Yes, ma'am.
So are you not shading, or do you shade?
This is shaded, yeah. I'm sorry, you probably couldn't tell. These are shaded, yeah. All right, let's try one more of those. This one's a tiny bit different. What's different about this one?
You have the 2.
I got the 2 there. I don't want a 2 there. Can you divide by 2? Absolutely, but what do you have to do? If you're going to divide by 2, you have to divide everything by 2. So everything gets divided. So x minus 4 absolute value is greater than 2. Now, I'm old, I do this for a living, and I'm taking calculus. So when I see this, I immediately think distance. We're talking about a distance here. The distance between some number and 4 has to be more than 2. The distance has to be more than 2. So what are the boundaries? 2 and 6. That's not an or equal to, so those dots will be open. The distance is more than, so we'll shade out. And our answer is negative infinity to 2, union with 6 to infinity. All right, now I'm really going to trip you. How about this one? Well, it's different. What's different about it? You are absolutely amazing, Brenton. You are amazing. He says if I'm going to do distance, it has to be a subtraction. So this is the same as x minus negative 4. So on my number line, I'm going to have a negative 4. Who was listening a little while ago when we had the equation of a circle? And I said whenever you have parentheses like this, you always use the opposite. Anytime you group them together, whether it's absolute value, parentheses, brackets, whatever it happens to be, it's the opposite. So here's my negative 4. The distance has to be less than 6. So what are my boundaries? 2 and negative 10. 6 this way, 6 this way. Right? And then want less than this time, so that means I will shade inside, and my answer is negative 10 to 2. Very good. Now, I totally want you to do your very best to try to understand what's happening up here. But some of you are going to try to memorize stuff, and I want you to memorize the right thing. Memorization is not the way to go, but if you're going to memorize, see how this number is in the middle of the problem? See how this is kind of in the middle of the problem? That's what you put in the middle of your number line. And then what do you do with that number? Count that many both ways. Don't do it backwards. Don't get confused and put the 6 here. That number's in the middle of the problem. It goes in the middle of the number line when you do this.
Will you ever give us a negative on the far end, or is it always going to be positive?
Put a negative here. Okay, now let's talk about that. This is absolute value. What do we know about absolute value?
It can't be negative.
It's always positive. So if you had a problem, I'm not going to do this because it would be just like deliberately tricky. But if you had a problem like this, that would automatically be empty set because there's no way a positive can be less than a negative. On the other hand, switch it around and it would automatically be all real numbers because a positive is always greater than a negative. Everybody okay with that? All right, you'll get a chance. You can practice some of those in your homework. Okay, a few more things here, and then we'll be done. Because I don't see, someday I don't see you, so I have to make sure I use all my time wisely. Next on the list, we've kind of already gotten a head start on it, but let's review quickly. If I give you a couple of points, we'll use my initials this time. And I said, find the slope of line LF. We talked about this earlier. The point that I made before was, if lines are perpendicular, they have opposite reciprocal slopes. Well, you can't even do that until you know how to find the slope. So how did we do that? Who remembers?
Y over Y.
So it's gonna be y over x. So we'll subtract our y's, 3 minus 1. Subtract our x's. So 3 minus 1 over 6 minus negative 3 gives me a slope of 2/9. Any line that is parallel to line LF will have a slope of parallel. What do you know about parallel lines? What's their slope? Same. So any line that's parallel to this one will have a slope of 2/9. Any line that's perpendicular to LF will have a slope of negative 9/2. Because what do we know about perpendicular slopes? Opposite reciprocals. Opposite reciprocals. All right. I don't want to bore you out of your minds. Everybody okay with slope? Everybody know how to find slope? The next step in the process then is to write the equation. So we'll use point G for Griffin and point S for Spurgeon. And we are going to write the actual equation of line GS. Before lunch, we wrote some equations, just a couple. What were they equations of? Not lines, they were circles. And we said if we're gonna write the equation of a circle, we had to have two pieces of information. What did we need to have? We needed to have the center and we need to have the radius for a circle. Now, for a line, we need two pieces of information. Do you know what we need for a line? We need the slope. Absolutely gotta have the slope. Do we know how to find the slope? Yep, they didn't tell me. I'm gonna have to figure it out, but I know how. What else do we need? We need any point. The y-intercept would be the very best one to have, but actually any point will suffice. If I have the y-intercept, my job is like cut in half. But I can make it happen with any point. So to write the equation of a line, I have to have my slope and I have to have a point. Well, I've got 2 points. I'm just going to pick one of them to use. It doesn't matter. I'll get the same answer regardless.
So then for the slope, you just do.
I'm going to do my slope, right. So Brenton, what will that be?
Was it y minus y?
So it'll be 2 minus 8.
Over x minus.
So 1 minus negative 3. So what is that? Negative 6 over 4 or negative 3 halves? Now, this is where we kind of diverge in the wood. We got a couple different ways to go. Yes, ma'am.
For the point, you can use either two of those.
Either one.
Okay.
And I picked this one because they're both positive.
Yeah.
It's just easier for me.
Okay.
But either one will give you exactly the same answer. At this point, you need to write the equation of the line. You've got everything you need. Now, there are 2 main ways to do that, and I don't care. I don't know which way flips your switch. How do you write equations of lines? Y equals mx plus b. You know what that's called? That's called the slope-intercept form. Because m is the slope and b is the y-intercept. So you see what my point was? If I knew my y-intercept, I'd just plug in m and b and I'd be done. But I don't know it, so I'm gonna have to find it. Do you remember how to find it if we use this strategy?
This is y minus y.
You're thinking of the other strategy, Brenton. Hang on to that thought. I want to get this one done before we do the other one. But yeah, hang on to that. That's the other way.
Can you just put it on?
Yes, sir. Bingo. The point is your x and your y. So you're going to go back to this is your form right here, and you're going to say 2 equals negative 3 halves times 1 plus b. Y equals mx plus b. So 2 equals negative 3 halves plus b. What does b equal? Can you do this without a calculator?
3 1/2.
Well, you could say 3 1/2. I hate mixed numbers, so I'd say 7 halves personally, but 3 1/2 is fine. So y equals negative 3 halves x plus 7 halves is your answer. If you use the slope-intercept form, which is fine. But as Brenton has pointed out, it's not the only form. Does anybody remember what the other form is called? Point slope. Somebody said it. You're right. The point slope form. And it's the one that looks like this, Brenton. Now again, no one in the world cares which way you do it. So if this is your way, then tune me out. If this is your way, then pay attention, let's review and practice. I'm a point sloper myself. This is if I found a couple points out in the hallway and needed to write the equational line, this is the way I would do it. How does that look? Well, now our point is x1, y1. So y minus 2 equals negative 3/2 x minus 1. So y minus 2 equals negative 3/2 x plus 3/2 if I do my distributive. And lo and behold, groupies, what happens when I add 2 over here? I get exactly the same equation. We'll practice another one of those. Obviously, next time we're together. So someone be in charge of reminding me that's what we're going to start with. Okay? At this point in time, you should be able to do all of the P1 and P2 homework. If you've got questions, you can ask them in class, ask me before, some kids ask me during lunch, that's fine. You've got to stay up with your homework though. Do not wait until the night before it's due. There's way too much of it. Alright? And I want to share one thing with you, don't know if you care or not, but I got scanned last Wednesday, got the results on Friday, and I'm good to go for 6 more months. I start maintenance, chemo, and services. Woo! And you are free.